So another development, I have trimmed down my Perma Proto board. I cut power rail off of it using a Dremel tool and one of the disc cutters. And this edge came out really well. I was hoping to salvage the power strip on both sides, but I was wary of getting too close to the holes, I guess, or the mounting points on this side. But thankfully, hey, oh, hello. I didn't damage any of the through hole connectors, or connection points, or pads, or whatever you want to call it. I didn't damage anything over there, so that's good. And I have a nice smooth edge here. Not exactly straight, but I freehanded it, so hey. And it rests up there against there really well. A little bit of play in one direction, but hey. Something that's kind of interesting is this where I ended up kind of cutting some of the holes in half. You can see the through hole plating on each of the pads, and a high quality circuit board doesn't just have copper on one side or two sides, and with components soldered straight on there. A high quality circuit board actually has copper plating on the edges of the cylinder, or it has a little cylinder of copper plating completely through the board, and that is to allow to guarantee that you get a good connection, an electrical connection or continuity between the two sides of the board. It's essentially a guarantee that this hole on this side will connect with the corresponding hole on this side, and you will have a good electrical connection. If you didn't have that plating or that through hole plating, then you would have to rely exclusively on your solder to make the electrical connection, and that's what it's there for, obviously. But the solder is also there to provide mechanical support. And when you're using solder, you have to be more wary of making sure that you get a good flow and that it goes completely through the board. Having the via plating it helps with the soldering, because it will allow heat. The copper will carry the heat from the soldering iron down along the copper plating, and solder follows heat. So there you go. One other thing I would like to talk about. I'll pull this out of the closet. Let's see. Nice little toy I got. I'll pull this out later. But what this is it's a microscope, and I got this through a rewards program at work, basically an incentive program, and I'm looking forward to using that thing because it has a 5 megapixel digital camera on it, and can magnify by several hundred times, and it's got a little 4-inch LCD screen on it. But it also you can hook it up to your computer, or you can hook it up to a television and use that for a monitor. So what I could conceivably do is hook that microscope up to my computer and then use some desktop capture software to record a video of what's under the microscope. And I've had a little fun with it already. I took a look at this buck converter, and something that's kind of interesting that you won't be able to see on the camera, but it came out in very nice detail under the microscope, and you can't really see it very well even with your eyes, if at all. But yeah, right there, that surface-mounted capacitor. This board actually has a bit of a defect. There's a hole straight through the board on one side where that surface-mounted capacitor is connecting, and you can actually see straight through the hole, straight through the board. So that's a bad solder joint right there. So what I'm ultimately planning on doing is getting this project finished, getting it put together in its box, then taking this buck converter, which I know it doesn't work anymore, it's burned out, but what I'm going to do is I'm going to take this buck converter and start taking lots and lots of pictures of it and start removing the components, and once I have all of the components off of the board, I will then be able to use the microscope to examine the construction of the PCB and reverse engineer it and learn how to make one of my own. And this is something that I actually already have the parts for, and I could look on the data sheet and look at the example circuits, and that's ultimately what I'm going to end up doing. But just to get a better understanding of how this is put together and how it's assembled, and also to reclaim the heat sinks for my own use, I'm just gonna I'm gonna end up at some point in the future ripping this apart and really thoroughly examining how it's put together and taking a look at exactly how the copper has been etched. So I'm going to turn the camera off for now.